The point of this video is to help you start answering questions about a set of data using NumPy. It goes along with the Jupyter Notebook, so make sure you check that one out as well. What I intend on start doing, I think, sometimes if I remember to do this, I have the video up here and the things that I think that are important inside the video. All right, so we restarted everything, so we got to bring in the libraries. The ones that we're going to use today are NumPy, Matplotlib, and datetime. So we're going to take a datetime and convert it so that we can use it however we want to. And the first thing that we're going to do is do this gen from text using a comma as the delimiter, knowing that that's going to be from a CSV file. This Seattle 2014.csv is just a file that I just downloaded off the NOAA website, and you can just go in there and check it out. So matter of fact, why do I have the ... There's 3 dots there. The reason being is because we're sitting in an AY21 folder. I need to come up one to the lesson 13, and then come up another one to course 40, and then come up another one into MA46, because that's where my data sits. So I'm going to go up 3 times up to MA4086, and then down into the data folder where that Seattle 2014 sits. So let's see that. So I'm coming up to MA486, and I'm going down into data, and let's see, Seattle 2014 sits in there. And let's go ahead and bring that sucker up. So again, 46 data Seattle. And so this is just what the file looks like. You can see that when we pull this data in, it's going to give us nan for all these strings. Just understand that the only thing we're going to get are the ones that have numbers in them, or the only things we'll be able to use now. When we get to pandas, we'll be able to pull all of this information in, and it can be different types. That's when we get to pandas data frames, but we're not there yet. So we're only on NumPy. So just understand that when I pull this thing in, we're just going to get the ones that have numbers. Everything else is going to be a nan. And the 3 columns that we're going to use are precipitation. So it's station 0, station name 1. Let's see, 0, 1, 2, 3. So precip is 3. Dates are in column 2, 0, 1, 2. Actually, I guess there's 4. So it's dates, precip, tmax, and tmin. Tmax is in the 6th column, and tmin is in the 7th column. Yeah, again, indexed from 0. So let's go ahead and bring it in. F9, if you come up here and look at data, like I said, the nans are all wherever there was text. And then this 2014-01, and there's another number after that. It puts it in the scientific notation. Don't worry about that. We will snag this information in a few. And then 3 is going to be, I believe, is that precipitation? Yeah, that's precipitation. And then if you slide over, 6 is going to be the max, and then 7 is going to be the min, and that's in degrees Celsius. I'm sorry, it's in tenths of degrees Celsius. So we're going to have to, again, I had to go to NOAA's website to find out what these numbers actually meant. You don't have to do that. I'm just going to tell you. So we're going to take max temp. I'm going to bring it in. I'm going to get 1 to the end. Why am I starting at 1? Because remember, the top row was all text to tell you what the columns were. And so that's no good. It just has a nan there. I can't use that data. So I'm going to start at 1 and go all the way to the end. That's what that means. And I'm going to do it in the 6th column, the 7th column for min, and the 3rd column for rainfall, for precipitation. Press F9, and I think I printed off the max temp, and you can see these are all in Celsius. Now, why are they in Celsius? Because I took the max temp and divided it by 10 to get rid of that tenths, because these were in tenths of degrees Celsius, and then I did the conversion here. You multiply by 1.8 and add 32, and you can convert Celsius temperatures over to Fahrenheit ones. Okay, so really our first question here is, how many days was Seattle above 85 degrees Fahrenheit? That should be a relatively easy question, but let's just check it out. So plt.hist. So we're going to do a histogram, and I just want to do a histogram of max temp. And then, I'm not sure if you remember, but we got to do this show. You don't have to do this, but it's sort of what Python's expecting, so I'm just going ahead and do it. Otherwise, it'll give you sort of it'll give you maybe an error, not really an error message, but it'll tell you, hey, you didn't give me the show method. And what are we looking for? 85 degrees. So what we're looking for are the ones that are up here. Well, maybe we could count those out, but there's a NumPy allows you, numerical Python allows you a very easy way to do this kind of stuff. So max temp. So I'm not sure if you remember from last class, we talked about these boolean. So this is a boolean mask. And what it does is it gives you a false for all the ones where this statement isn't true. So for any NumPy array, you can give it a Boolean sort of question, and it will give you what's called a Boolean mask. So it'll give you a zeros or one basically for every single one of the data points in that NumPy array. So that's that guy. How about max? How do I actually find out what the temperatures were for that? So what you would do is give it the Boolean mask, temp greater than 85. What you're passing in is this data structure here, this thing that has a bunch of zeros and ones, and NumPy knows that, well, you really only want the ones. You don't really care much about the zeros, so I'm going to print off the ones that have ones in it. So 93.92. You kind of look up and so maybe that's the 93.92, and then 86, and you would, so it's kind of hard to see kind of what's going on here. So we're going to attempt to sort of figure out what days those are here in a second. But really, let's answer this question. So np.sum of max temp greater than 85. Is why can I use an np.sum here and not a count? Because these are just zeros and ones, and if I add 0, obviously nothing happens, and the ones are the ones that actually count. So what it does is it just goes in and counts the number of trues. All right. If you don't believe that, maybe you can go to np.sum. So let's just take this, Control C. Then this will give you the sum of the actual days of the actual numbers, right? So now are you getting 1,508? Why is that? Because it's 93 plus 86 plus 87 and so on and so forth. And maybe you want to divide by np dot, was it 17? I can just divide by 17 to get the mean, or you can do np dot mean of the same thing, just to prove to you that it's doing what it's supposed to do, I hope. Hopefully it gives us the same thing, and it does. Okay, so good. So how many days was Seattle? So if I'm answering this particular question, I can say, well, it's just 17. If you want to answer some other question like, well, what was the average value of those days that were above 85? You can use this np.mean, you can do the sum and then divide by the total number. We could basically take this and substitute it under here to make this so that it's more general. So if I changed 85 to some other temperature, then we would be able to get the correct number. Anyway, so that's the quick introduction of these Boolean masks and how you use Boolean masks in order to do things with NumPy. The next one is, what days did these occur on? Obviously, right now, I wouldn't want to sit here and go, okay, January 1st, January 2nd, January 3rd. Okay, that's not fun for me. So we're going to use, okay, let's just do this. Let's go with data 1, 2. Now remember what data 1, 2 is. It's that 2014-01-01. We know that is the first day. So if you pull up data, it's that piece of information that's right there. Remember when we looked at the headers, we saw that was going to be dates, and that is the date. So it's January 1st, 2014. The question is, how do we take that and turn it into a date time? And I'm sure, to be honest with you, I stepped through this in order to do it myself. First thing I do is I made it an int, and then we get that, all right, and then I made it into a string. All right, so now that I own that, I know how to turn a string into a date. And so remember this parse, the string parse time, and then I gave it this, the capital Y, because that's 2014. It would, if it was only just 14, then I would give it the small y. I gave it this the %m because it was 0, 1. If this had Jan on it, then we'd have to do the %b. And this 0, 1 is the %d. So basically, you're doing. So to turn this sucker into a date now, I'm going to hit F9, and then we can print date 1. So print date 1, F9. And you can see that this thing is now a date. So if I came up here, you can see it's a date time type. I don't want to do that just for one of these. I want to do it for all of them. So what I've done next is I've called this new list. It's going to be a list, right? So you can see it's list comprehension. We're going to run in here and we're going to say do this for every single one of them. So I did it for this one for the data 1, 2, but now I'm going to do for D into data 1 to the end. Again, I'm using 1 to the end because that first one for data 0 is that nan. I don't care about that. I'm going to the second column because that's where the date's at. And then I'm grabbing every single piece of information or every single date that's in that column, and I'm going to pass it into this thing that we just created in order to create the dates. So that's just what that does. And then you can pull up dates, and you can see it's a whole bunch of dates, right? So it's all of them. And then I'm going to call this new thing just to show you that you can turn you can take something besides a number and turn it into a NumPy array. So as long as they're all the same type, you can do that as well. So np dates, let's do np dates. All right, np dates 1 is a datetime object. You can't really see it up here. Let me pull this down. np dates is this guy, so it's hard. You can't pull it. It gives you an error. You can't. It's not supported. This list of this NumPy array of weird objects. NumPy doesn't like to, or I shouldn't say NumPy. Really, it's Spider doesn't want to show you what those things are. But you can do what we did here and do np dates just to check out what it is. Okay. So on what days does the temp exceed 85 degrees in 2014? So there's a simple answer to that one. I'm just going to take temp right now, temp, set it equal to 85, so we can change it maybe later on. I'm going to have a boolean IDX, and that's going to equal to max temp greater than temp, print BIDX. I forgot this. All right, and then we get that boolean. It's probably, yeah, this is exactly the same one we already had. We just called it BIDX. And then max temp BIDX index. And we get that. And then, unfortunately, we can't do this. You can't, well, let's see what BIDX is first. BIDX F9 is an array. Let's see. BIDX. We cannot do this. You would think that maybe you could do this, but the problem is these aren't indexes. It's a Boolean mask, and lists, straight Python lists, don't know how to interact with a Boolean mask. NumPy arrays do. So if I try to do dates BIDX, we're going to get an error. Right? You can't do this. Doesn't make any sense. Blah blah blah. But what we can do is NumPy dates, and this gives you the date time. So now you can kind of read this thing off. July 1st we had one. July 8th we had one. July 11th, and so on and so forth. You can see the dates that occurred on. So this next little piece says, oh, well, I want to print it out nicely. I want to have like some code that will kind of go through this thing and give us some maybe a nice way of doing it. So I'll just show you one. I mean, again, these implementations aren't the only way you can do it. There's lots of different ways we can do this. But I'll just step through BIDX. And then if B is true, so again, if B, right? Because remember what BIDX is. So let me turn it off again. Just a bunch of trues or falses. And then what we do with the both of them. And if it's true, then I want to do this, maybe just print it off. And we'll tell it to do, let's see, date. So we're going to use that list dot str. We're going to format the string. Let's see, how do we want to format it? And you got to use a single quote here. If you try to use a double quote, it'll close out your F string. You wouldn't want to do that. Percent. And we're going to use a capital B, so it'll be like January or February or whatever, instead of just Jan or 01. Dash. Again, this is, you can do anything you want to here. Dash percent. So the entire month listed out, a day, and then in the year. And then we end that. 18 spaces because we're using the entire word, January, September, October, whatever. And then maybe max temp I. Right. So not only do I want to know the date that occurred on, I want to actually know this is six spaces for this temperature. I want to have a decimal of 0.2, and it's a floating point number. And we can end that, and let's find out what happens. All right, so to print it out pretty, right, so nicely, I guess I should say, July the 1st, it was 93.92, July 8th was 86, and so on and so forth. You can see, I mean, maybe the dashes kind of look funky. You can go back and change that if you want to. I don't know. It looks fine to me. It looks nice and pretty. And I experimented with this 18 here so that it would push it over. I think the first time I did it, I had a smaller number, and this thing was pushed over to the left. But I experimented with it and found out that hey, I like 18. Be okay with that. All right. So the next thing that I'm going to show you is something that I already kind of got written in here. This is an introduction to dictionaries. And so I think up here when I talked about this, I said I'm going to introduce you to a dictionary. The next question is, well, can you count the number of days in each month? So in July, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could simply just say 9 in July, 1, 2, 3, 4, 5 in August, and 3 in September. We could certainly do that and just count them out every time, but I like for the computer to be able to do that. So that's what we're going to do here. The first thing I'm going to do is I'm going to create this dictionary that just basically goes, so this is dictionary comprehension, right? So this is your introduction to dictionaries is probably more advanced than I probably should have done, but so this is dictionary comprehension, and what I'm doing is I'm putting a month here. This will give me January, February, March, April, May for every I from 1 to 13. So what happens is I gets 1, it gets substituted in here, so that'll be January, because all we're asking for is the month, and then I'm putting a 0 in. I'm initializing this dictionary. So if it F9, you can see, let's go find it. Months is this, and oh, by the way, it orders it in the spider. It will order it from A to Z, right? So it will make it alphabetical. That is not true in how it's stored. And generally, it's stored by the number, how we put it in. So over here, April is 0, August is 0. So what a dictionary is, it's just like a list, except the keys don't have to be integers. So before, a key had to be integer. Now I'm letting a key be a month, the actual word for the month. And here what we're doing is the same, sort of the same business that we were doing, enumerate IDX or BIDX. So we're enumerating this thing. So I've got the index and the true, false. That's right. So if B, then it's going to come in here. So if B is true, so in other words, it's one of the ones that would have showed up over here. Then it's going to do months, and then it goes and grabs the date. So what does that code right there do? For dates of that particular index for that BIDX. So for example, whatever, so this is true, the index to that BIDX index is going to get passed in. And so now I own you know, what that index is it gives me the place in both the temperature. Let's see where we're at. It get the temperature and the date, but the first thing I'm using is just the date. So go in and grab that date, and then grab the month, and then add 1 to that month. The way that you use a dictionary is that's the index. The index is the actual name of the month, and then I'm adding 1 to it. So let's find out what happens when we do this. F9, and we can pull up months again, and you can see that July had 9, just like we said. August had 5, just like we counted out, and September had 3. Because what I did was I used that as the index. So when it went through and it found an index that was true, then it just went in and grabbed September and then added 1 to it. And then we just print them off. So F9. And this is how you increment through a dictionary in the order that it was set up. So for M being the month that's in the month.keys, all it's doing is printing out January, and it's telling you that there was 0 in there, so that's what's going on here. And then when you got to one that actually had a number, so when M was July, then months July would be 4. No, month July would be whatever it is, so it's 9. So you go to months, month July would be 9, and that's why it printed out 9 there. Months August would have been 5, and month September would have been 3, and so on and so forth. Okay, that's good there. So now let's move down. What I want to do next is just show you np.where. So this function np.where and sort of how it compares to a boolean mask. So remember a boolean mask temp is greater than 85, F9. Remember boolean masks are a true or false for every single element in that NumPy array. Rainfall, IDX, let's just e.where. So all I'm trying to attempt here is just to show you what the difference is between those two. And what it returns is the index. Instead of this entire list here, it gives you an index to all the ones that are true. So now we can just do maybe dot. So it returns a tuple. So the first tuple is our first member of the tuple is the array, and the second member of the tuple is telling you what sort of data is in each one of these tuple, right? So F9. So if I just looked at the 0th member of this tuple, then it's that guy, and then maybe some count. I don't know if count didn't like count. Oh, length of it. That's dot length. Maybe dot length. Let's see if dot length is 1. Didn't like that either. Maybe you'd have to do this in order to find the number. Okay, 17. So it's 17, just like we said before. Okay. What if I wanted to maybe put, let's see, let's do IDX. I want to use this information here. So I'm going to say IDX is equal to np.where, and then I'm going to put, matter of fact, I'm just going to copy this. I should have just copied it from the beginning. C, Control V, F9, and then let's check this out. Let's see what this guy does. And so in this case, sort of another way to attack the problem is to just use that IDX, and you can see July 1st. I mean, this is maybe a quicker way to do it than this whole business up here. Again, it turns it into a list. All right, let's look at maybe some other things that you can do with a Boolean mask. So max temp greater than 80, F9. Again, a Boolean mask here. Let me pull it up. You can see there's a bunch of trues in there, in the summertime months. Maybe rainfall, we haven't used that yet, so I'm going to say maybe rainfall is greater than 0. So in other words, you had some kind of rain thing happen, and you can see a bunch of trues and false, and it was like it rains about half the time. Let's do this. Some 150. So 150 days it actually has rain there. Wanted to do it for mine. I was sort of curious here after looking at so about 150 days out of 365. It's pretty almost half the days in Seattle has rain. What if I wanted to find the number of days that was above 80 and the number of days that it was so in other words, both of these things have to happen. Let's look at that. Maybe max temp is greater than 80. Now this isn't going to work, but I'm going to show you what does. And then rainfall, I don't think this will work, is greater than 0. And F9. Okay, so it doesn't like this, but what it will do is what's called a bitwise. So what does a bitwise do? If I have a Boolean mask here that's 365, another one is 365, then what it's going to do, it's going to give you for each one, so for each day, it will look and see, is this true and this is true. So F9, looks like it happened a couple times. And if you wanted to know, let's see, let's copy both of these and put them on there, Control C, Control V, print IDX. It should give us exactly the same. And yep, it does. And then let's do np.where. So np.where. Again, I'm going to do 2 of these Boolean masks. So I'm combining now the Boolean mask and the np.where command just to show you some of the power that can happen. So let's grab both of these and throw them in my np.where command. And now, okay, so it looks like it occurred at index 213, 222, and 223. So if you wanted to know those dates, all of the information, look at this 0, and then it's lower, be like Jan, Feb, that kind of stuff, and then the day. So the month thing, we know it's 2014, so I didn't print out the year. And then it's going to go to the max. So it's going to give you the max temperature for that day, right? Because we said, hey, I want it to be greater than 80, and I want the rainfall. I want to know what the rainfall is, and I'm going to round it out to 4. So let's run this and see what happens. And so August the 2nd is 84.92, obviously greater than 80, and it's greater than 0 here, and so on. So 96. So it looks like 96 that day, and then the very next day, August 12th, it was at 80 and 0.5. So it got a little bit of rain that day, but the next day it rained half an inch, which is, I guess, significant. It looks like maybe a cold front came through. I don't know. Pretty neat. All right. Next thing that I want to, or the last couple things we're going to do here is np.mean, max temp, temp 80. I think we've already done that. Maybe I did that up here already. Let's see. Yeah, so I was doing some of that stuff up here already. I just want to rehash it. Let's do a quick histogram. It's a plt.histogram. And so I just want to show you that you can do, let's go grab, let's go hist. I'm going to do max temp, max temp, where min, so now I'm going to mix these up. So I'm going to do min temp is greater than 40, bitwise, and max temp is 5. So between 40, so when the minimum temperature is greater than 40 and the maximum temperature is less than 85, let's do this histogram. Hopefully this video is not too long. I know I'm having to type a bunch of stuff in. So this won't tell you, right? So technically, min temperature, you know, I mixed in the boolean, the min temperature greater than 40 and the max temperature greater than 85. Or I could have done like rainfall. Could do rainfall. Let's do that. Rainfall. It's all sorts of things the boolean mask can combine